In 1644, Evangelista Torricelli, an Italian physicist and mathematician, described the first mercury barometer in a letter with this phrase: "We live submerged at the bottom of an ocean of the element air, which unquestioned experiments is known to have weight." It was once considered that air had no weight, and that kilometers of air above the surface do not impose any force on the bodies under it. However, Torricelli questioned this premise, proposing instead that air has weight and that we live in a sea of air that exerts a pressure.
Hi, I'm Sharan Arun and I'm going to explain about what is atmospheric pressure. Our Earth is surrounded by a layer of air called the atmosphere. Gravitational force of the Earth constantly pull the atmosphere toward itself. Due to this, the atmosphere exerts a pressure on the surface of the Earth as well as the object present on the surface. This pressure exerted by the atmosphere is called the atmospheric pressure. Atmospheric pressure is also known as barometric pressure. It is named after the barometer. It's a pressure within the atmosphere of the Earth, as I said before. The standard atmosphere has a symbol of atm. It's a unit of pressure defined as 101,325 Pa, which is equivalent to 760 mmHg. This would be the atmospheric pressure formula. pH equals to P0 exponent negative mgh over kT. pH is the pressure at height h, P0 is the sea level pressure, g is the acceleration due to gravity, and k is the Boltzmann constant, which is the ideal gas constant divided by Avogadro's number, and T is the absolute temperature, and m is the mass of one air molecule, and all of it will conclude to a atmospheric pressure formula. The atmospheric pressure is the weight exerted by the overhead atmosphere on a unit area of surface. It can be measured with the mercury barometer, consisting of a long glass tube of mercury inverted over a pool of mercury. As you can see, by measuring the height of mercury is gone up, we can measure the atmospheric pressure on a certain place.
Now, let's take a look at the atmospheric pressure experiment, which is the can crushing. As for the material, you need tongs, a bowl, ice water, 150 ml water, empty can, and also a stove. First of all, the ice water is poured into the bowl. Then, the 150 ml water is poured into the empty tin can. The can was then placed on the stove and the heat was set at mid-range. Once the water starts boiling, the can is removed. What will happen when the can is submerged into the cold water? Well, let's take a look at the results. How did that happen? Well, this experiment not only demonstrates atmospheric pressure but also the Newton's second law, which is unbalanced forces. It is also a great experiment to study about the condensation effect on pressure. Steam displaces the air in the container above the water when the water heats and boils. When a soda can is submerged in cold water, the vapor soon condenses, leaving a vacuum in the can's interior. This causes the air pressure in the can to decrease. The consequent difference in air pressure between the outside and inside of the can causes a large inward force on the can, results in crushing. As the can is being crushed, the volume in the can decreases. This influences the air pressure, and at a certain point, the pressure inside and outside of the can are balanced and the crushing of the can is stopped. That's all from us on atmospheric pressure. Thank you for watching.